Timer. Who else has used Python in the past? Miguel, first time. Hector has some knowledge of it. What about the rest? Let's try to make this a little bit interactive. Otherwise, it's just going to be me talking for an hour.
Hello.
Hello.
I worked on Python in the past 2 years back, and moreover, I'm just new to this session.
Okay.
Yeah.
Well, I believe what we will be doing, if you have done any Python in the past, should be extremely straightforward. Okay. I have been coding in Python for a couple years. Yeah, Thomas, I don't think you're going to get a lot from here, but if anyone has a question, Thomas probably will be good for that. Okay, so for today, we're going to be building just a small excuse generator. If you've been part of the course already, in JavaScript, we do the same. So for that, I'm going to do everything locally on my machine. If you want to follow, you can access the project, Interactive Coding Tutorial, Excuse Generator. I'm going to share the URL here. Oh, I can actually use the chat. That's nice. If you want to check the code directly and start working from it, it has the very basics of a boilerplate in React. So you can, if you don't feel comfortable with the command line and working directly in your terminal, then you can create a template. I've already done a copy of it. I'm working with a Mac. I'm not very experienced with Windows, so I won't be able to give you a lot of details on how to do everything in Windows. But if you have any questions regarding Mac or Linux, I'll be able to explain them. So let's get started with a little bit of code. So I created basically this folder called excuses, and the first thing that I'm going to do is I work with Vim, so I'm going to create a file called app.py. If it's your first time seeing any Python at all, for the Python interpreter to understand that your file is a Python file, it has to has the extension .py. As you can see, if you have any software that recognizes based on the extension, this is the small symbol of Python. It's two snakes with each other. So basically, Python is an interpreted language. What that means is that you can run it and go through and execute functions while the Python program is running, and the program will understand what you're trying to talk to it and answer you with purpose. So for example, if I were to run the Python REPL, that's what this is called, it allows me to write Python interactively. So I can do a print statement, hello world, or any operation that Python allows. But what we want to do today is write some Python directly on a small script and execute that script. So for doing that, we need a file. That's what I was doing. I created this app.py file in which we're going to be working on. Let me make this a little bit bigger so you guys can see. Okay. So just to test the waters out, I'm just gonna execute a print statement. Basically what print does is that it reads a bunch of characters and shows them in the output of your terminal. If I do hello world and I save this file and then do Python, or I have a shortcut for Python called py, and put the name of the file that you want to execute. As you can see, it returns me the string that I wrote inside of the program, hello world. This is the basics of basics on programming. So just being able to create a file, write some code inside of it, and execute that file. Now, what we want to achieve with Python for this specific exercise is first understanding how to store a group of strings that we want to cycle through, and how to make those strings randomized so that we're going to have a random excuse, and it's not going to be always the same thing. So let's imagine that an excuse has to always have a who, a action, a what, and a where or when. So that allows us to produce a bunch of excuses that can be repeatedly done through these 4 events. I was mixing up JavaScript with Python. So to do comments in Python so that they are not executed, you have to do the hash sign. This allows you to create comments. So what you will see is that if I execute this program, the lines that I wrote on top do not generate any issues because they are informational for other users. So far, is there any questions? Everything is making sense? Okay, I'll take the silence as a yes. Okay. So for doing this, creating a who, an action, a what, and where, we can start just by creating a couple variables that store that information. So let's say that we have an action. Let's say that who is my grandma. Then we have action, ate, what, my homework, and when yesterday. If I want to print that, basically what I have to do is put it together inside of a print statement. And that's going to show you the information that you're looking for. My grandma ate my homework yesterday. So that's the basic elements. What we have here on the left side is a variable. It's sort of a box inside of your computer where you can store information. And what we are storing here, we're declaring that it's been stored with 1 equal, and we're storing a collection of characters. So when you have a collection of characters, this is called a string because you're stringing together characters. They are denoted in Python with double quotes. And if I'm not wrong, single quotes are also valid, yes. They have different behaviors in Python, depending on the type of quotes that you do. But double quotes seems to be the most common rule for writing in Python. So what we're doing right now is creating this excuse build as 4 different excuses. But what we want is a little bit of variety. So the next step for us would be to create a collection of excuses. So this collection is what's called a list in Python. It's called an array in JavaScript. There is different implementation of the same type of data structure. In this case, this Python list is declared with the brackets on either side. This is what tells you that it's a list. And basically a list is an organized collection of items which are next to each other and can be accessed on memory. So what do I mean by that? So if I try to do this, save, you're going to see that it prints the entire list, and what I want is 1 element. One of the things that I can do with a list is accessing an element, and the list organizes all its elements by index, and it starts with the index 0. So it can go from 0 all the way to 3 because you have 4 elements. So if I were to execute this piece of code, now we see that it returns me the string instead of the array. So now we have an idea of how we can accumulate a bunch of elements And now what we want is to repeat the same process that we did with who, but we're going to do it with the other fuses, elements of the fuse, sorry. So now we have 4 different ones of them. And the problem that we now have is that we want to randomly access each one of them. So for that, we need external help, because the thing is that what we want to achieve is randomize these elements, and creating a randomization function is extremely complicated to do from scratch. So we're going to do our first import. So we're going to import random. And doing import random, basically what it says to Python is that find the standard random library that you have access inside of Python and provide the entire scope of this app, the access to the functions that are defined on that module called random. So random provides us with one very nifty function group. Called print. Here's the random module. Oh, choices is the one that I want. So basically, random choices, you pass a list to it, and it picks one of the elements from it. And you can do other nifty things like providing a weight so that one of the elements gets selected more often than the other. So this one, for example, gets 10 times more often inside of the randomization than the other 2. So choices. So I can do random choices, and very verbally provides us with the infrastructure to just I have the py. Oh, I haven't saved. Yeah, there it is. So as you can see, what random does is that it returns me the first element that it finds inside of the choice that it selects from the list. So I get a small array with crushed inside. If I were to do the same thing with all of them, you'll see that it returns the same thing. So the issue that I have here is that I don't want an array, and that's happening because I'm picking choices, the plural. So I want several choices. But if I want just one, it returns me the string. So now I have a randomized fuse generator, basically built from 4 arrays and a randomization function. You'll see that every time that I execute it, it has different inputs. So the doc ate the keys before the class, the dog crushed my homework right on time, my turtle crushed the car when I finished. Any questions so far, guys? Everything is making sense?
Yep, I'm following along. Makes sense.
Awesome. Okay, the last element that we want to make this code a little bit more clear is to organize this logic inside of a function. So we can do a couple things to make that happen. We're going to have a very simple function, obviously, because there is no complexity in what we're doing. So we can call it generate SKUs. But instead, we're going to ask the user to provide the elements. Okay? So if we want to show anything right now, you'll see that there is nothing being outputted in the terminal. It's because everything is inside of the function that is not being executed. So this function that I created now has the logic to show the options. So in order for me to execute that code, I have to execute the function. As you can see, it keeps on working. So this allows us a couple things. That provides us the ergonomics to keep on playing and modifying things to improve even more what we're building. I was thinking that maybe we can, because this is extremely straightforward, we can maybe extend a little bit the functionality of our excuse generator. So one of the things that I would think would make for a nice CLI would be to provide the way for us to not only read and answer to the terminal, to also receive information from the user. So we can add another option so that who it's always the person that is doing the excuse. So let's imagine for that we're going to have to do a little bit of digging. So let's find a way for us to read from the input, that is the arguments that are provided by the user when they execute our program. So in every CLI program inside of any terminal, the data that you pass to the execution, that you usually do it this way. For example, Python app.py, and let's say I'm going to call it name, and the name will be Daniel. So we want to have access to this information that the user is passing. So this is called a flag, and this is both together, the flag and the data are called arguments inside of any CLI. So let's find out how we can access the arguments in a Python program. So apparently, Python provides this very nifty, simple library called sys. We can import it. And let's print whatever is inside of it, just so that we can check how it works. And now we have the information that we're looking for. So the first thing that we have to do is verify that we're being provided the flag that we were looking for. And that means that the next thing, in theory, should be the data that belongs to name. So the first thing that we see is that this is a list or an array. So we can extract the elements from that array. So the first thing that we need is to find the flag. So let's go for the very straightforward solution at the beginning. And let's say that the second element should be who. Who is equal to the second element. We're going to clean it up a little bit more after that. So this one is expecting for a bunch of choices. So what we can do is the who that already exists, we can extend it. So we can do who and or push, preferred push. So we don't need to reassign. Now when we print who, you'll see that my name is inside of the list. Oh, this is not how it works. Then, yeah, there it is. Okay, as you can see, now my name is part of the list. So you can put anything that you want through arguments. The thing is that we have to verify in some way that the argument actually is related to the flag that we're looking for. So,
quick question, Daniel. So
yeah.
here, you said the second element. What are the 0 and 1 elements here?
Let me show you. If I print the entire list that is produced by the arguments, the first element will always be the name of the program. So it returns app.py. The second element, the one in the index 1, is the first flag that I provided. And the third element, which is the one that I'm accessing, would be the data related to the flag.
Got it. Okay. And it's 0, 1, 2 again.
Yeah, it's always in Python, everything that it's a consecutive list, it's always starts with 0. It's 0 indexed.
Okay, thank you.
Okay. So what I'm doing here is very simple. I'm just appending to the list who. That means adding to the list. I'm appending the third element inside of the arguments array. Okay, that's basically what I'm doing. And once you have that information, we're passing it down into this generate excuse. The generate excuse is picking one of the options from this 4 plus whatever I wrote. Make sense?
Yeah.
Okay, awesome. So now what we want to achieve is some sense of security. So the first thing that we need is that to make sure that we always pass the argument that is related to the flag. So let's try to find something a little bit more complex that can help us in Python to make sure that the argument is really that. We can do it manually. So for example, we can first pick everything. I think it's, see if it was like this. I'm not sure. Print it first. I think it's like this, maybe. Ah, here it is. Okay. So basically what I'm doing, this is called accessing a slice. So I'm accessing from the first index to the end, basically. So the 2 points means until, and because I'm not putting any value, it goes from the first to until it reaches the end. So I'm doing this just to access all the possible arguments that I have inside of my view at the moment, inside of my arguments. So let's store that somewhere. Args. Okay. So now we want to check for if args contains, see if contains the string name. That's where the first thing that we're looking for. So in order to do that, we can either do it a for loop, which is the most simple way for accessing that. We can do, see what this is doing. Sometimes compiler go crazy. It's even inventing things. So what I want you to do is go through every element inside of the arguments. Let's just print them. There it is. Okay, so now we're achieving what I wanted. We have access to the direct element to verify that that argument is the one that we're looking for. So what we can do is, oh, and we also need the next argument that follows it. So the first thing that we can do is check for the argument that we're looking for. So if the argument is equal to dash head name, the argument for the time being. Okay, so we can access the argument. The next thing is, if we get that argument, we want to check that the following one is the one that we're looking for, and then we can break from that. So for doing that, we need to be able to make these arguments also be organized based on index. So for that, we can try, for example, a range of arguments size. This that works in. Okay, now we're gonna have indexes instead of the actual arguments, if everything went properly. Nice. There it is. Okay. So now I get the indexes for the arguments that I have provided for me. So what I need is to check if args index equal name equal dash name what I want is to print name. For printing the name, I need args index plus 1. Okay. So the other thing that we need to verify is that if this thing exists at all, because we don't know that. So we have to do and just to verify if it's possible. And the next thing that we have to do is to check if args index plus 1 doesn't start. So let's see, how do you Python have starts with? We can do it directly on it. Awesome. So this is in theory a string. So we can do start with. And we're basically checking if it doesn't start with this to verify that the data that it's being provided, it's not false. So for example, let's first try the happy path. You can see it shows it to me. Oh no, I didn't save, sorry. About syntax. Yeah, it works. So as you can see, very straightly, very simply provides the name from that logic. But the thing is that what happens, for example, if I don't provide anything? It throws an error. Why? Because I'm trying to access an element that doesn't exist inside of the array. And we have to protect against that as well. So for that, I believe probably Python has more secure interfaces into lists. So let's take a look at that for a second.
Daniel, another question.
Yep,
So,
go ahead.
Command line arguments, when you
Mhm.
say name Daniel, is it like a key value pair?
No, the way that it works in the terminal is that the program provides to the terminal provides to the program a list of all the things that were written inside of the arguments when you execute it. So the first argument will be the name of the file that executed the program.
Mm-hmm.
Then the second argument will be whatever you put next to it, and every space between elements, it's a new argument inside of the array. And they will
Okay.
always be strings.
Then why do we put the hyphen?
It's a common practice. If you see any CLI tool, it
Mhm.
will ask you to provide. Let's say, for example, I do ls. If
Right.
I do ls just by itself, it shows the files. But if I do ls-a, it shows the hidden files. Oh, let me go to a repository with that. So if I do ls, you see this. If you do ls-a, you see the hidden files that has a dot before them.
Right.
And if you do ls-la, it also provides the information of the permits inside of the file, when it was last modified, things like that. It also gives you the size of the file. So providing flags as arguments to CLIs, it's extremely old practice, standard across the entire industry. So that's the reason why we do it.
Okay. Got it. Thank you.
So in line for you guys to get used to that, that's the reason why I'm trying to expose you to that and the complexities that it brings along. So the first thing that you're going to have as a complexity is actually verifying that the flag that the user is providing is being provided, and also making sure that your app doesn't explode because it wasn't provided. So I would have to do another check for this. So I'm trying to first figure out how to access an element inside of Python, inside of a list in Python, without the entire thing exploding. So let's see how to verify the Python list. Oh, okay. So one idea they provided is we can do next this if index plus 1, which is what I'm trying to do here, is less than the entire length of the app minus 1. Because, for example, this has size length 4, but it reaches all the way until the third. No, it's less. Yeah, it works. In this case, it works because it's less than 4, so it's all the way from 0 to 3. It doesn't include 4. So I can do another and here, and this will protect me first from making sure that the argument is called name, then that there is something next, then that the next argument doesn't starts with -- meaning it's not another flag, and then I can print it. So let's see how that works. Now if I do pyname, it just goes straight into the program. It doesn't crashes. If I do pyname -- doesn't crashes either. It doesn't recognize this. But now let's make something out of this entire thing. So if we have it, then let's append it, or we can even modify it. So let's say, see if this works. I'm not sure. So this, for example, would enforce that the name that you pass will always be index queues. So it doesn't work if I don't pass a name. But if I pass Daniel, then Daniel broke the car during my lunch. So the funky thing that is happening here is basically I'm checking all the arguments. If I find a name argument and it has an option has been provided for it, and the option doesn't have dash dash, then what I do is I create a new array so that I can respect the rules of this function that expects an array. And what I put inside of it is the data from the arguments that I pass. Make sense?
Yeah.
Okay. So if we want to get more complex with this, so we can experiment a little bit. So let's see if we can actually, for example, pass an entire array like we did here to the arguments. So for that, let's go back to printing them. So let's imagine for a second that we pass array.
Daniel, question while you're
Yeah.
typing. Could we have like you said, name Daniel? Can we have name Daniel, excuse, broke, like multiple parameters, or do we only have to pass a
Yeah.
list?
You can have infinite. So I can do Daniel, then I can do excuse, I don't know, tall. And you see that you get them all.
Right. Okay.
So we can modify it to, instead of expect for that, it can be who sample.
Right.
And instead of do action. So if we do that, we change it to who. We can repeat it with the action, and we're pretty much doing exactly the same thing. So instead of who, we do action. So let's say we want to do this specific action. And as you, Daniel failed my homework when I finished. It makes no sense whatsoever. Right. So what I wanted to allow us to achieve now is to pass a list. So how do we do that? We can modify the logic of how we handle this to have everything strung together. So if, for example, we did equal Daniel. Oh, let's for a second. This, because it will break. Okay, so now you see that it doesn't separate them because everything is just stick together. If we enforce this rule where it's one thing and it has to be divided by an equal, then we can get a completely different behavior. So for example, we can do that rather. And then we get a huge list. And if we apply those rules to the list, then we can simplify the logic a lot. In this case, we wouldn't need anymore to check the indexes. We can check on the values themselves. So argument. Let's modify this to if argument starts with dash dash who equal, then what we can do is split they're doing a replace. It's also interesting. I think this actually replaces on place. See how the argument looks after that. Doesn't. It modifies it. Maybe it returns string. Yeah. Okay. So what we can do is we can replace the start, and then we can probably split by the commas, and we will get a list. So we can do who equal this, what this returns. So you'll see that when I execute this, I get that Daniel, brother, anything that is on my list. And you can keep on doing that type of thing. And the next step that you would do with something like this, for example, would be to find online a list of names and people just to abuse this thing. So, for example, you can say maybe add something that says who online and search for a list of names. Yeah, there is an array of first names. Where we find this raw? Okay. For example, this is a huge list of names that we can actually use. So the first thing that we need to figure out is how to bring that list into our program. So this is the URL. Now let's look for how to pull from the web. Is it a JSON? Oh no, it's actually a .py file. Let's see if we can find something. Okay, we have the request API. So let's see if we manage to execute that. Oh, no.
We will have to import requests.
Yeah, we're gonna have to import requests as well. I don't even know if it's part of standard library, but let's try it. And this is stored in here. So let's see what we get from that. No module name requests. So we're probably gonna have to install requests. Let's see. Yeah. Oh. This is for which Python? Oh, it's okay. 3.11. Okay. Let's see if it runs. There we go. So we get a humongous list from online without doing absolutely anything. It's a bunch of bytes. That's the problem that we get from this one. Let's see if we can find a JSON one. List of names. Okay, let's start with this one. Should be easier. Come on. Okay. Now we're gonna need a serializer because we're getting a string. Do type of type valid bytes as well. So how do we read from the file once it arrives? Python read. Oh, there is a way for with request itself. I do JSON. Awesome. Now we have an actual list. So if we put here at the end JSON, we do type R. Awesome. As you can see, it's a list. And now we can do something very simple. This.
Daniel, could you copy the JSON URL and put it in the chat so we can follow along?
Sure. There you have it.
Thank you.
And whatever we write here, I can put it in a gist in GitHub so that you guys can check it out if you want. Don't worry about it. Okay, so this will allow us to have a humongous amount of options to create random things. So we can do CLI app.py. Ruby the cat right on time, and we're gonna have so many names. It's a humongous list. And you can apply the same principles for every single one of them. So for who, for action, so we can call this who. And we can pretty much replace, we can replace everything. These two concepts are, in my opinion, one of the most important to understand while learning to program, is basically being able to play around with any idea that you have. And for that, you need to understand one basic principle, which is how to ask questions to a browser. So as you can see, I'm not super experienced with Python. It's not my main driver, but I'm aware of which are the functionalities that I'm looking for, and it's easier for me to find what I'm looking for on the web. So, for example, in the case of finding the JSON, I first found a .py file, and I saw that it was going to take me too much to sort it out and find a solution to that. Because what was going to happen is that I was receiving a humongous byte array, which was stored inside of a string. So I was going to transform those bytes into a string, then parse the string, and then get a list from that and pass it to the generated queues. So instead of going the overhead of doing all that solution, it's easier to just get a JSON, which produces an entire array automatically. So guys, this is going to be it for today. Do you have any questions on any of the concepts that I explained today? Okay. Well, I'm gonna make a small gist of this. Let's show you guys how you do that. If you're ever interested in doing it, you can go to gist and just create yours. Use think Python use it. Source. There you have it. Small implementation if you're curious on how to use arguments, and the most practical implementation, which is getting data from the web. I'm going to create this guys, and it's completely available for you guys whenever you need it. If you want to check the code and you're curious about it. And that's pretty much it for tonight. Have a good one and good night. It's been a pleasure.
Thank you.
Thank you, Daniel.
No worries.
Thank you.
Thanks for accepting the invitation.
Welcome.